The NIO ET7 premiered the outstanding certified drag coefficient of 0.208 on the 22nd of September 2021, and by so doing achieved an aerodynamics performance of its category of passenger vehicles amongst the lowest ever worldwide. This feat was accomplished thanks to the superlative efforts of the NIO aerodynamics development team. NIO emphasizes such importance to this attribute as it's an intrinsic aspect of the car's efficiency and designates the vehicle's fundamental behavior on the road in all driving conditions and thus contributing to the user's ultimate experience. Reducing air resistance is crucial for reducing a vehicle's energy consumption and thus increasing the journey range, as well as directly contributing to increasing maximum acceleration, increasing maximum vehicle speed, and through the optimizations of the vertical downward forces, ultimately improving the vehicle's handling and lateral performance. The ET7's impressive aerodynamics results are final realization of a body of work and effort spanning over 800 complex full vehicle computational fluid dynamics simulations and over 120 hours of intensive wind tunnel testing sessions. In essence, we can summarize the fundamental benefiting factors in a series of aerodynamics performance enablers that contributed to reducing the aerodynamics air drag resistance by overall 25% and concurrently improving the vehicle vertical downward forces by 5% in both the front and rear vehicle's axes. Some of these enablers can be readily identified in the vehicle's active aerodynamics system complex, such as the active grille shutters that impede the air flowing into an uncontrolled environment, such as the engine bay, and efficiently guide it along specific trajectories that enable an increase in the intensity of the forward low pressure zones, and hence a direct reduction of the air resistance. Additional extreme effort was placed in perfecting the vehicle's passive aerodynamics enablers, such as the leading edges on the front end system, including the transition of the bumper to the hood, the bumper to the side fenders, and the lower body airflow management. The rear spoiler, as well as being a critical design relevant feature, is concurrently one of the most integral aerodynamic devices. This component alone contributes to over 2% of the total air resistance reduction and 30% of the total vertical downforce, and is subject to the most scrupulous development process, as it needs to adhere to the conscripted design themes with limited flexibility to the fundamental form. In the ET7, we were able to develop a striking concept that extended the benefit of this device over the full width of the car by overlaying its function in areas such as and above the rear taillights. One discernible contradicting feature that you evidently can notice on the car's profile is the upper frontal sensor farm array that includes the side cameras and the LiDAR device. As would be apparent, this area likewise required extensive study, insight, and consolidation in determining its least detrimental configuration. An important part of the LiDAR that you may have noticed is that the front-facing surface is not flat. It's what we describe as a sculpted surface. It is unusual for a sensor cover to have this kind of feature because now the surface becomes an optical element, which will affect the performance of the LiDAR and therefore requires extensive optimization. I do hope that all NIO users will join my team and I in the very near future in experiencing firsthand the outstanding performance that the ET7 can deliver, as much as the NIO aerodynamics team have endured in developing this milestone of electric vehicle advancement. From an aerodynamics point of view, the ET7 is the perfect sedan.